Hey, look where we left off. Got the spinny boy, look at me go. And we got a cube, and we got a sphere. Very cool. So I thought we'd make a video just to do some cleanup, I think. Our project is getting a little bit messy. So I thought we'd, shuffle things around a little bit, do some refactoring. So that later on when we start tackling a little bit complicated things, it would be nice if it was as easy as possible to change and add functionality, new shaders and so on. So I thought we'd do that. A little bit low energy today, but it's fine. Got some tea going. Maybe I should make coffee actually. Well, whatever. Also, my Visual Studio has been a bit crashy today, so hopefully it doesn't crash all too often. Apparently I can't split my view. Look what happens if I try to split my view. I'm just gonna open up look what happens. Freezes. And it's gone. So yeah, Visual Studio, great program. Usually code in Sublime, but I keep it in Visual Studio for now, just to make it as followable as possible. Okay, so first of all, I'm actually gonna split up a few things from main just to have them accessible. We want to have keys. Would be nice to have impossible key checking. Would be nice to be able to check somewhere else. Camera would be nice to check somewhere else, and so on. Because I actually want to start with splitting out the camera, and to do that we want to split out all of this updating things. Want to keep that somewhere else. So I just thought we'd use a simple globals function, a globals file, just to have neat, convenient stuff in there. So I'll just make a globals function, globals file. Excuse me. Hopefully I don't trip on my words way too much today. And I'll make a globals C++. All right, so we'll make like an extern glfw window. So I want to keep the window variable global, and just to let you know, to make a global variable, you declare an extern in the header, and then we'll define it in the C++ file in there. That way, that's sort of like a static. When you make a static in a class, you declare a static, but if you make it a variable, then you have to declare extern. C++. And of course, to declare a glfw window, we have to include, or we could forward declare, but let's just include it. It's fine. I'll include glfw, and then we have to include. No, nothing. Yeah, let's keep that at first. I would love to split the view right now, but cannot. So, okay, so let's see then. Instead of doing this, making a variable in main, I'll just be setting the global variable. So I'll include globals here. Want to be careful only to include globals in C++ files. We never want to include globals in header files. Okay, so here we go. Unresolved external symbol, glfw window. Yeah, so that's because I didn't define it in a C++ file. So this is a declaration, sort of like a function declaration. It's a declaration of a variable, so we have to define the variable somewhere for linking. So I'll just define it here. Include globals. There we go. And it compiles and it runs. Okay, cool. That was scary. All right, cool. So now we have the window as a global, so that's cool. I will move out delta time as well, so I will move delta time into here. So I'll do a float delta time, and in globals h, I'll make an extern time stuff. like so. So that in main I will look, someone's singing outside my window. Okay, so instead of declaring delta time, I will just define or set it here in main. Let's see if that works. Yeah, it works fine. I also want to do this with the mouse stuff, so that mouse movement and things are also global. So I am going to mouse stuff. So I'll make an extern. I'll actually make a vector. So I'll make a vec2, and that's going to be mouse position. I'll have to include glm for that, and I'll make a extern mouse delta. Cool. So I will define it here. So I'll just do glm vec2 mouse position. Whoops. And vec2 mouse delta, like so. And you know, instead of getting the mouse like this, I'm actually gonna set it from a event function, event handler. So I'll just make an event function for mouse position, and just to show you what that looks like, here I have the glfw documentation, and we have this set cursor position callback or pos callback. So, and it looks like this. It's a window pointer, double double. A double double. So I will just do handle mouse pos, and I'll do window, and then two doubles. So this can be mouse X and mouse Y, and in here I will just simply set the global. So mouse position is equal to vec2 mouse X, oops, mouse Y, like so. So now it's being set from an event rather than we pull it every frame. So that's cool. Doesn't really matter that much, and I'll set that callback here. So set cursor, course, cursor, pos callback, like so, and then that's going to be go to handle mouse pos, like so. Okay, and let's just see if that compiles at all. Oops. Okay, mouse pos was not resolved. Mouse pos. Okay, I'll actually do position. I think it's, yeah. Let's do mouse position instead. Position. There we go. Mouse position, and I will change this to mouse position, like so. Yeah, okay, it works. And of course, we don't use it right now, but we are. So in main here, so I'll still let main handle that sort of thing, because that's, you know, main is still the main loop. And instead of doing this, I'm just gonna make a vector here. So I'll do a vector last mouse position is equal to mouse position, like so, and then calculate delta time, and then in calculate delta mouse movement, instead of fetching this, I'm just gonna do vector through, or no, I'm gonna make mouse delta is equal to mouse position minus last mouse position, because now there are two vectors. So that's nice, and then we don't need any of this. Oh yeah, and then we do last mouse position is equal to mouse position here, like so. So now we got the mouse delta and the time delta. And then let's just update this code here. So let's see, camera rotation. So that's gonna be mouse delta Y, and here's mouse delta X. And hopefully that should be it, yeah. And now, yeah, okay, so that still works. Cool, so now we moved mouse position and mouse delta out into the globals file. And now let's just yeet the camera out of here and into its own little thing. So I will make a camera file. So I'll make a camera header and a camera CPP, like so. So I'll make a camera struct here. And in here I'll have a float for yaw and a float for pitch. we'll have a GLM vec3 position. And yeah, let's add some projection stuff as well. So we'll add aspect and FOV. Yeah. Let's actually also have a bool for. Oops. Well, that worked out great. Let's have a bool for perspective as well. We'll set that to true by default. I'll set the aspect to 1 by default and the FOV to 60. Yeah. Include GLM. So that's gonna be our camera setting. So our camera our camera system is gonna handle both the projection, so you know if it's orthographic or perspective, and also the look at stuff. So we will bake all of that into one neat system. Hold on 1 sec, sorry. This is the worst part of tea, having to like dump out the little bag. Maybe we should get one of those like pinchy winches. Pinchy winches. Oh. Oh! Baby. Okay. So now that we have the camera struct, Man, my I gotta buy like a new, like, what do you call it, like a thing for the microphone. Anyways, so now that we have the camera struct, let's actually put that into globals. So we're gonna make a camera stuff. I'm gonna make a camera cam external. So that's actually gonna be the current camera. So we're gonna include camera here. Define it here in the CPP, like so. So we're gonna have a global camera struct here, and that's just gonna be where the data lives. The one camera to rule them all. So we're gonna actually make global functions. So we're gonna make a function that is update. Well, I'll just call it cam updates, like so. And then we'll have a glm mat4 cam matrix to fetch the current matrix of the camera. So that's going to be the view projection matrix. I'll also make some other functions, like I'll make a quaternion function for cam quat. So that's going to get the rotation of the camera. And then I'll make a vec3 cam forward and glm vec3 cam right. So those are some helper functions to fetch the basis vectors of the camera. And actually, let's define these right now, because they're, whoops, we've done this math before. I'm actually gonna include glm gtc quaternion to get the angle axis functions. So I will do angle axis. No, I can't do this here. No, yeah, because I need a global. Okay, never mind. Let's do that in the CPP in this instead. So include camera H here, and here I'll also include the globals to get the global camera. And this is why I only want to include globals in C++ files, because you know if I will include globals in camera.h, then it will be a circular dependency, because camera includes globals, which includes camera, which you know that will break. So unfortunately, gonna have to implement all of this in the C++ file, but that's okay. So let's see, cam quat, that's gonna be return angle axis. Let's move this quaternion include. Oops, to there. It's gonna be angle axis. So we're gonna do the yaw. So I'll do cam yaw around the y-axis. So that's gonna be our yaw rotation, and then we're gonna multiply that with the pitch, and that's gonna be the right axis, like so. Let's do using namespace here. Also, never want to use namespace in headers. It's a bad idea. Always do use namespace in C++. I mean, you could do it in headers. Like I don't know. It's not a rule. I like to put them in C++ files, but you can do whatever you want. Okay, so this is the quaternion. So we do pitch first around the x-axis, and then we yaw around the y-axis. So we do first pitch, then yaw. And that's our camera quat, and then our camera forward is simply our cam quat multiplied bit with the forward vector, and that's minus f if we think about, okay, what's going into the screen. That's going to be our default camera forward, so we just rotate that by the cam quat to get the, you know, transformed camera forward. And then our camera right is just going to be the same, but instead of the forward, it's going to be the right vector, and that's the x-axis. Like so. And then, okay, so cam update. So here we want to update the camera. So we'll first do... Actually, let's not do that yet. Let's do the camera matrix first. So I'm going to return... so I'm gonna let's just make the look at first. So we'll do a look matrix is equal to look at. So the I is cam position, the center is cam position plus cam forward, up is just the y-axis, and then if I'm going to do math for matrix. Let's call it view instead. Excuse me. So the projection matrix, and that if cam perspective. So if we're doing perspective, then prog matrix is perspective. Fov is the cam fov. Aspect, I'm actually not gonna use this cam aspect. I changed my mind. Let's just poll the aspect here. So I'll just do, because we have the window, so we can just poll window. No, I changed my mind again. This is gonna be easier. We're gonna actually have the aspect here. Yeah, that's actually gonna be easier. So we are going to God, I'm so, my head can't think. Yeah, okay, right. So in the perspective here, we are just gonna, next second is aspect, so I'm just gonna do cam aspect, and then near. We could set those as globals as well, actually. Let's do near is equal to 0.1, and float far is equal to 100. Like so. Oops, cam, put near. And else, then we'll do an orthographic camera. So we'll do left. Okay, so let's do ortho height. Let's define that as something. This is usually how you do orthographic settings. So we'll do, let's see, what's our left is gonna be cam ortho height times cam aspect. Oops. You want half of that actually, because the left is going to be the position of the left plane, so we want the distance from the left to the right plane to be height times aspect, and you know the bottom and the right, we want the distance of those two to be just the ortho height. So I'm just going to do float half height is equal to cam ortho height divided by 2. There we go, that one's great. So we'll do, instead of cam ortho height, we're just gonna do half height times cam aspect. Right is gonna be half height times cam aspect. Bottom is gonna be half height times cam aspect, and top is half height. Cam aspect. No, what if I? No, this is gonna be half height. Oh, I'm so dumb. Right, so bottom. So bottom is of course gonna be half height then, and then top is gonna be half height. But I've forgotten something. I've entered positive values for all of them. Of course, that doesn't make any sense. How can left and right be the same value and top and bottom also be the same value? They're both half height. We of course have to set what's going to be positive and negative, and left is going to be negative half height, right is going to be positive half height, and the same thing with up and down. Down is going to be negative, top is going to be positive, so we have to specify that as well. We could do the other way around and, you know, flip the orthographic, so we could do it like, you know, top is negative and bottom is positive if you wanted, and then would flip everything upside down. So we can sort of do what we want, but let's just keep it the same. And then we could not specify, we could, you know, skip specifying near and far, but I'm gonna specify near and far because we have those on the camera. Like so. And then I'm just gonna return these two, multiply together. Okay, that's totally what I wanted. There we go. Seems to work. So cool. So now we have the mathematics at least in the camera. So it's going to be one global camera, which I think will work fine. I think this is going to be the easiest way to do it for now. So let's hop on over to main then, and let's just remove everything that has to do with the camera. Move that away, and then I'm gonna remove this. So I removed everything that was camera movement and also view projection, because that's not gonna be now it's gonna be handled by the camera system. So if I then do GL uniform matrix for FV, I can do U view projection 1 false, and then I'll give the value pointer to cam matrix, like so. And let's see what happens. Looks pretty good. I wonder if this is actually right, or if this is something went weird. Let's put the camera a little bit further back. Oh yeah, okay. One thing I did wrong is the field of view is, of course, I entered that in degrees, but perspective expects radians, so I'm just gonna convert that to radians. Okay, so now it's black, so that's cool. Let's move the camera back a little bit as well. So I'm just gonna set the position to be a little bit back. So I'll do 0, 0, 5. Yeah, that'll be good. Okay, great. So there we go. Of course, the aspect ratio doesn't work, because if I do this, for example, you know, clearly you can see it's getting stretched and acting weird. So we're gonna have to set the aspect ratio as well. And I'm actually gonna use the callback, the frame buffer resize here. So that gives us the width and the height. So I'm just gonna use that to set the aspect of the camera. So the aspect is equal to width divided by float height. Because remember, we have to cast one to float, otherwise we'll get an integer division and it won't work as we expect. So let's see. If I change now, yeah, okay, so now it works. Whoops. Whoops. Cool. What? Fucking goddammit. Very cool. Although I do believe that the first aspect, I don't think this is right, because this doesn't look like a square, and this is a cube, so we shouldn't expect this to be rectangular at all. So we might have to set, you know, the initial aspect ratio, just to have that be correct. So let's do that. Where's that done? Let's do it. Oh, we can remove these now. Don't need those anymore. For calculating delta, time, and mouse delta. Put that there, and I'll just do set initial aspect ratio of camera. So we'll do glfw get frame buffer size. Yeah. So we'll do window and then 2 ints width and height. 2 pointers. Oops. Like so. And then I'll just set the initial aspect to be width divided by float height. Like so. Very cool. Okay, so now the initial looks good. So now there's actually a square. I don't know if there's a way to just like force these events. There might be. Maybe let's just check the GLFW. Maybe I'll just Google GLFW force events on start or something. See what happens. Maybe not. Event processing. Window size. Don't think so. Oh well, whatever. Doesn't really matter. Cool. So that's now we factored out the camera, so that feels pretty good. Let's but it can't move because we haven't implemented that yet. So let's actually implement the movement of the camera real quick as well. So I will set a global bool to just be like we have. I'll do cam control. So when this, so we're gonna set this cam control to true if we're capturing the mouse. Oops. So let's just hop into globals and I'll add bool cam control and I'll set that to false by default. So let's see here. So we're going to main and we will into here. So instead of this mouse camera, I'll just set this cam control. Like so. Could have maybe checked if the cursor was captured or something. So now I have this, and I'm actually gonna remove this mouse camera here. I was gonna remove this fucking print we had in the beginning. Cool. So that's that. And then let's hop into cam update to see what we can do. So let's first update rotation then. So I'll just do cam yaw plus equals. I'll do mouse delta dot x and then cam pitch plus equals mouse delta dot y. Can I see what happens? Oh yeah, we don't call a cam updates, of course. So let's just call that in main. So I'll call that here. Update cam. Like so. Oh, okay. Well, we forgot to check the bool first of all, and then it's very, 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 very quick. So let's go into let's first exit out of this if we don't have cam control, and let's also add just a static. Let's just a constant float cam sensitivity, and that's gonna be equal to 0.01 maybe. So it's times this value. Times cam sensitivity. Oops. Like that. And now hopefully, okay, so it doesn't move, and if I hit right click, then it moves. Okay, but of course I fucked up and I made it reverse again. So I'm just gonna have to do minus equals instead. Go, quite nice. Okay, and then let's add rotation, and then let's do movement then. So we'll do the same thing we did before. We'll make sort of a move, like a total move that we gather from each input. So we'll do if glfw get key. Is that it? Okay, it was. Okay, so we'll do window and then glfw d. Actually, I wonder if glfw releases 0. It is. Okay, so we can use if it. Let's just do that. So if that, then move plus equals. So that's going to be cam right. And then if glfw get key window glfw key a, then move is minus equal to cam right. Then we'll do the same for forwards and backwards. So that's gonna be forward. So we just do plus equals cam forward, and then s. Oops, it's gonna equal cam or minus equal cam forward. And then we'll do up and down. So that's gonna be move plus equals, and then we'll do space. So that's gonna be plus equal just straight up in world space, and control. Was it left control? Yeah. And then left control is gonna go downwards in world space. Cool, and then we'll do cam position, whoops, plus equals move times delta time. Let's see. So if I don't have cam control, then nothing happens, but if it's right, then there we go. We're moving. Oh, okay, it's still a little bit sensitive, and it's a little bit slow to move. So let's actually make a speed here, and I'll make it a little bit slower here, so it's 0.3 maybe. And I'll multiply this by cam speed. Could also make these variables on the camera if you wanted, so we can, like, you know, change the speed with scroll or something maybe. It could be cool. So let's see. Okay, so now it feels pretty good to me. You're of course free to tweak these values as you please. But I think it feels pretty nice. Cool, so now we moved out the camera mathematics to convert into matrices, the movement, and so on, all of the settings into its own system. So that feels pretty nice. So now main is a bit cleaner. Only 200 lines. We can start. We're gonna start trimming away a little bit more though. I'm just gonna take a little bit of a break. I won't screen this time. I swear when I come back. Still sorry for that. Okay, see you in a bit. Hey. All right, let's continue our cleanup. So, well, we can get rid of like all of this. Because all of this was just like doing our quad, like our hard-coded quad. And since we have the mesh system now, we can get rid of this. I'm just gonna just nuke that. And I'm also gonna just expand a little bit the shader program things here. I'm actually gonna make a material struct, so that will hold both the that will hold both the shader program, and also the textures, because I usually like to clump those two together. So I am gonna make a material struct here. Whoops. And it's gonna have a GLU int, so I'm just gonna make a program like so. So I will do a function that loads a material. I'll still give it the same thing. Like, so we'll load a vertex and a fragment shader. So I just hook this up first. I'll remove this. I will keep it in the C++ file. I just removed it from the header file. Because we don't want to call this directly. We want to use this load material function. So I'll just make a material here. Material mat. Then mat And dot program is going to be equal to load shader program. Path, frag path. I'll return that. I'm wondering if we should. Yeah, fuck it. Let's do it. Let's make some helper functions for like uniforms and stuff. So let's do helper functions. So we'll do a function called void material use. I'll just send it in. So I'm gonna actually make that bind the shader program, but also bind all of the textures that we want to use. So that's gonna be a convenient thing when we add textures to the material. And then I'm gonna do material set, and then that's gonna take a name and a value. So we don't have to call those like GL uniform whatevers. So I'll make 2 for now, because I know we're setting floats and we're setting matrices. So I'll make functions for those. I'm gonna make that a const ref because matrices are huge. Include GLM. Like so. So let's define these in the C++ file. Let's do a create implementation there. Functions. There we go. So here we'll do GL use program, mat program, like so. And in material set, so we want to get the uniform location. So I'm just gonna save it into GL unit here. Location. So I'll do GL get uniform location. And here we need to enter a program, and I don't want to send a material in. I would rather just have to set one and then just set the material on the currently used program. So I'm just going to save it here. So I'm just going to make a static GLU int current program. Like so. So now I can just do current program. Whoa, okay, that's what I wanted. Current program here, and name is going to be name. And then I'll do GL uniform 1F on that location with the value. Like so. Not the most performant code ever, because getting uniform locations is actually quite heavy duty. But you know, we could easily optimize that by, you know, caching the uniform locations in the material structure or something, but it doesn't really matter. We don't care. I just want to make code that's easy to work with. So I will do the same for matrices. So that's going to be GL uniform matrix for FV. Then we see location, and we're gonna have 1. We're not gonna transpose it, and then I'll just give the pointer to. Oh yeah, I'll use the value pointer function actually. Why not? Am I even using GLM? Yes, I am. Okay, I need to include the GLM. What was it? GTC type pointer? Yeah, there it is. So I'll include GLM GTC type pointer to get access to the value pointer function. Maybe now it works. Ah, okay, cool. I don't care about that just yet. So now we can load material, and we get this material struct. Then we can use it, and then we can set material values much easier by just inputting the name and the value you want to set. So that's going to be a little bit easier to work with, I think. So we don't have to just cache these uniform locations all the time for every single uniform we want to do. So I will, instead of saving this as GLU int, then I'll just do it as a material. I'll just call it mat. Why not? So we'll build material instead. And then, I'll just use it. Material. Use material. Jesus. Material. There we go. Okay, so let's get rid of all of these actually for now. That's quite clean. Texture loading we will move in just a sec. Aspect ratio, blah blah blah. Okay, so here we're setting time. So here I'm just gonna do the material. Whoops. Material set. That's gonna be U time, and we're gonna set that to time, like so. And here we want to set material set U projection, and that's gonna be set to cam matrix, like so. And here, yeah, here we want to do then material set U model to model matrix. And then we actually don't even need to save it. We can just do okay, just pop that in there right away. And then the same, then I can do, just gonna copy this translation here, and just put that in here, like so. And then same thing here. Just copy all of this, put it in here in this set. Cool. Let's see if it works or if it just crashes horribly. Oh my god, it actually worked. I didn't expect that. Okay, so now what we do is that we load material like this. Then we use it. And after we've used the material, we can just call this convenient material set function to just set parameters or uniforms directly. We don't have to, cache them into a GLU int and stuff. Not very performant right now, but it is easy to. It is quite easy to optimize, so it's fine. We don't need to actually worry about that performance too much. So let's move textures into this as well. So we'll have it be like a texture is tied to a material. So when we use the material, we're actually also binding all the textures nicely. So let's do that. So I'll go into shader.h, and we're also gonna have an array here of textures. So I'll do 4. Yeah, whatever. Doesn't really matter. I'll define. I'll be a nice coder. Let's do a max textures. That's gonna be 4. Max textures. There we go. Yeah, so let's do so we'll do something like void material add texture. I'll send in a pointer, yeah, whatever. So we'll add a texture, and let's say we can add a texture by handle. So I'll do GLU int, like so, yeah, handle. Call it texture. We also want to have a texture num here, actually. Okay, so when we add a texture, we do mat textures, and then mat texture num, oops, plus is equal to texture. Easy as that. And then when we use it, what we do is we'll just bind the texture. So we'll do 4. Let's see. We'll use for loop through it. So we'll do mat dot texture num. Whoops. Plus I. We'll do GL active texture, GL texture 0, and then to get 0, 1, 2, 3, and so on, we can do texture 0 plus I. So that will just select the 0 plus ith texture. So then we'll do gl bind texture. Oops. GL texture 2D matte textures I. Like so. Should be good. I think that should work. I don't know, we might have to come back to this later, but it's fine. It works for now. So now we can have multiple textures bound to one material, and when we use it, we know that they are bound. So let's go into our main. And let's add a textures to this material then. So we'll do material, add texture, whoops. Matte, and then texture, that's gonna be load the texture. Wait, that went well. Texture.jpg. Let's put them in the assets as well. Assets, texture.jpg. They've been in the root for too long. All right, so we're gonna add a texture and we're gonna load the texture to add. So we're gonna load this texture.jpg. Just gonna make sure graphics course, this texture here, I'm gonna move it into assets where it should be. I'm also gonna move this texture too as well. And then here, so now we have all the assets in one nice, neat place. I'll actually remove these two as well. So I'll remove those two texture loads. Let's see what happens. Okay, so it works. So it compiles and it runs. So that's good. But of course, in the shader, we're not using the texture right now. So let's use it. So I'll just go into tests. Let's open it up manually. I'll go test frag. Yeah, okay, so we have the texture coordinate, we have the sampler here. So I'll just do, yeah, let's just do it at the end here. I'll do color is equal to texture use sampler 0 f text chord. I'm not quite sure if the monkey even has texture. Oh, it does. Okay, cool. All right, so now that we're using the material, we can see that this that it's, you know, tying together the material with the material. So that sentence went to hell of nowhere. So I'm just gonna make another material actually. So I'll do a material 2. And in the material 2, instead of texture, I'm gonna use texture 1, just so we can see if we can actually swap. Oh, it's texture 2, sorry. Just to make sure that we can swap materials and it should swap the textures with it. So I am going to, for the cube and the sphere, I'm gonna material use matte, and then for the monkey, I'm gonna material use matte 2. Let's see what happens now. Yeah, okay, cool. Oh. All right, yeah, because now when we're setting the view projection, matte 2 gets activated here and then it loops around. Then here is where we're setting the view projection. So we're always setting it for matte 2 and never for matte 1. So I'm just gonna move this down to when we use matte for the first time, just to make sure that it's being set for both. Let's move down there as well. So we're setting up each material properly. And now, yeah, there we go. So now it works. So now we can see that when we use material 2 here, material is mat 2, this texture, this guy texture, is kind of hard to see on the monkey, but this guy texture is being used for monkey 2, for the monkey, since he is using material 2. So now we've done that. So now we refactored that out in a nice way. So shaders and textures are being clumped into materials. Let's actually sometimes when you're in the corner, it can sometimes be a little bit. It sometimes like snaps. I don't know why. Oh, there it went. I actually don't know why. That is bugging. I think this bug is in Unreal as well. Something to do with locking, I think. So let's do something else. Let's refactor this mesh draw here. So I want to make it so mesh draw actually handles most of this, like model setting, view projection. It's going to handle a bunch more things later. That's going to expand quite a bit when we start going into lighting. So let's actually refactor that a bit now. So I'm going to make something called render data. So if we go into mesh here, I'm going to make a render data struct. And the render data is going to contain all the useful matrices that are going to be used, and also stuff like, you know, the current lighting and so on, and also which material to use. So I'm going to do a matrix. So it's going to have the view projection. It's going to have a model. So those are the matrices that it needs. And then we're going to have a material. I wonder if I should make a pointer. Maybe I should. Whatever. It doesn't matter. So that's a view projection, the model, and the material. So it has that in the render data. And then we're just going to fill that up later on with other stuff that might be needed. So when we render the mesh, we're not only going to send in the mesh, we're also going to send in the render data. Like so. Let's go into mesh draw. Oops. There it is. So here we're gonna bind the vertex array, and then we're gonna check some stuff. We're gonna set material to the material use data material. Oops. Why is that being a pointer? It's not a pointer. Material. It scares me that happened. Yeah, let's fuck it. Yeah, let's make this a pointer actually. It's probably best. I'll use for declare material here. Like so. Let's make it no pointer by default. So we're gonna material use. So I'll include material. No, not material shader. So we're gonna use the material, and let's expect a reference. Maybe I should have made them all pointers. Whatever, doesn't matter. So we're gonna use that, and then we're gonna set the matrices. So we're gonna set matrices. So we'll do material set. View model is gonna be the model, and then view projection is equal to data view projection. So now we're setting those. Was there anything more? I don't think so. Cool. Oh. Okay, so now we gotta go and update these things. Model is not a member of render data. Oh, it doesn't know about. Oh. Gonna include GLM here. Okay, there we go. So let's see. So let's go update these draws then. So I'll make a render data struct here. So I'll do render data. So I'll set the view projection right away because we have that. So view projection is going to be the cam matrix. Oops. And then I'll set the material to be I'll do point to mat there. So now we can actually get rid of these. And then render data. Oh, let's set that. Let's do that as a default, by the way. Let's go into mesh. I'll do model. I'll make these identity by default. Okay. Oh, oops. Getting some errors here. I'm guessing it doesn't have identities, so I'll include glm DTC matrix transform. Might need that. Yeah, okay, that was promo. Okay, so now we only have errors in main, which is like expected. So I will just set those two for first to see what happens. And then I just gotta put that into each draw call. Oops. Remove all of this. Okay, so at least it's drawing. You can see the ear of the monkey, and if I go in here, let's see. Okay, so here's the sphere, and the monkey head is in there as well. So they are being drawn, so that's fine. So the view projection and the material works. So that's being, the render data is being used there. And now I'm just gonna set the model matrix to be different for each of these draw calls. So I am going to set the model here to be. And that's going to be the identity. The cube is fine. That can be identity. And then for the sphere, I'm just going to set that to be translate. For gonna send the identity there. I don't like that parameter. And then we'll do vec3 2.5 like we did before. And then same thing and then for the monkey, we'll do minus 2.5 here. So that works. So now we've successfully refactored the render data, stuff like the projection and material, into this render data struct. So that's cool. So we can put stuff like lighting and stuff in there, and we don't have to, change the whole of everything. So it's quite useful to have this sort of render data struct. It's quite nice because usually there's a lot of data you gotta pump into each draw call to make it work, as you add more features to your render system. Let's also change the material here actually to that 2 for the monkey. There we go. Cool. Sweet. Great. So awesome. So now we've done. I might put load texture somewhere else. Maybe, I don't know. It's fine. It's down there now. It's cool. So now we have a little bit of a cleaner main. So there's not as much stuff going on here for having 2 materials drawing 3 different meshes and so on. But this will hopefully make it a little bit easier for us later to experiment, add stuff, make a little bit of a scene going. I might actually put the model as a. I'll do it later, whatever. Get a bit of a scene going and so on. Changing materials and objects. Hopefully it will be a little bit easier. So cool. Yeah. With that being said, hopefully this was somewhat okay to follow along with. I'll of course upload the code and everything. I just want to get through this because it's not very, like, we're just doing stuff that we've done before, like the camera controller and everything. Like, we've done this before. Now it's just like sort of a bit of a refactoring. So I thought I would just get through this, and I'm also a little bit sick, I think, so my head is a little bit spinny, but hopefully it was okay. So anyways, I'll see you guys next time.